Forensics Lecture 3-1, Common Types of Physical Evidence. Physical evidence at a crime scene can really be anything. And so every crime scene needs to be treated on an individual basis. Each has its own history, circumstances, and problems. It would be impossible to actually list all of the possible items of evidence that could be at a crime scene, but there are a few common types that typically yield significant results. So as you look through these this list of common types of evidence, you're going to see some that are things that you would expect. Blood, semen, saliva, documents, drugs, fingerprints, any sort of firearms, paint, plastic bags, anything that would be obvious to the investigation. And then after the body gets sent to the morgue, any organs and physiological fluids that the coroner obtains also becomes evidence as well. During the examination of the physical evidence, it's usually carried out by a forensic scientist, and so this is now done within the lab, and it's done for identification and comparison purposes. So identification is to determine the physical or chemical identity of a substance with near absolute certainty, as existing techniques will permit. Common substances labs are usually asked to identify are chemical compositions, presence of gasoline, blood, hair, semen, wood. Crime labs are frequently requested to identify the composition of illicit drugs. It may be asked to identify gasoline residue recovered from the debris of a fire, or it may be asked to identify the nature of an explosive residue, dynamite, TNT, things like that. Or it could be just to identify blood, semen, hair, or wood, or even if it's just to determine, hey, is this human or is it animal? The first step requires the adoption of testing procedures that gives the characteristic results for a specific standard. Once the results have been established, they may be permanently recorded, and this is so they can be used repeatedly to prove the identity of substance materials or suspect, materials through for years to come. The second step then requires the number and type of tests that are needed to identify a substance, and they must be sufficient enough to exclude all other substances. Once that an identification has occurred, then the comparison starts. And so when a suspect specimen and a standard reference specimen are subjected to the same tests and examination, that is used to determine whether or not they have the common origin. So forensic comparison has two-step procedures. Which properties are going to be compared are chosen, and then after examination, the forensic scientist needs to render a conclusion. Do they or do they not come from the same source? And this brings in the role of probability. Probability is the frequency of occurrence of an event. To comprehend the value of the comparison, the role that the probability has to be considered. But with many analytical processes, exact probability is actually impossible to define. So they have two groups of characteristics: individual characteristics and class characteristics. Individual characteristics happens when a sample can be associated with a common source with extremely high degree of probability. So when we say an extremely high degree, it's because it's not possible to state with mathematical exactness the probability of common origin. But it can conclude that the probability is so high that it defies mathematical calculations. So the matching of the characteristics of two fingerprints, the comparison of random striation markings on a bullet or tool, the comparison of irregular and random wear patterns on tires or even footwear, the comparison of handwriting, fitting together of irregular ridges of broken objects, like a jigsaw puzzle. So the tears of a bag, for instance, or matching sequentially made plastic bags by striation markings. All of these, it's impossible to give an exact probability, but you can rule out and how unlikely it is that it comes from different sources. And so this is an individual characteristic. When we look at a class characteristic, this is evidence that can be associated only with a group, but never with a single source. There is a frequent inability of labs to relate physical evidence to a common origin with a high degree of certainty, but high diversity of classes make their comparison very significant within the content. And so the value lies in the ability to provide corroboration of events with the data. The presence of more than one piece may lead to extremely high certainties that they originate from the same source. So investigators use the product rule to calculate the overall frequency. And this is a formula of how frequent certain combination factors occur within a population. So first, the probability of each individual characteristic is determined, and then those are then multiplied together to come up with the collective probability. So the chances are low of encountering two indistinguishable items of physical evidence at a crime scene that actually originated from different sources. So individually, they may not be that common, but together their presence is uncommon. And so that is what constitute a class evidence. When we're looking at DNA class characteristics today, we have modern technology that provides enough factors to allow analysts to individualize blood, semen, and other biological matters to a single person. And this is because they're looking at many factors to create this class evidence. And then with the databases we now have today, it makes it even more probable that it comes from this individual person. This is lecture for 3-1. There will be a quiz next class.